Okay, so this is a classic challenge, the switch challenge.
Mm-hmm. Yes. It's not only a great abstract concept for Java, but it's also an electrical engineering problem.
And we're going to take it one level further here. Really, this is the first opportunity they're going to have to write what I would call professional level code.
Yeah, it takes a bit to kind of get there, but interfaces are like they are the way to create code that other people can use. And sometimes it's hard to get an appreciation for them until you deal with huge code bases. But on a smaller scale, they just look pretty when you start using these levels of abstraction. Your code is succinct, it's clear, and it's object oriented. I mean, it's taking advantage of what Java has to offer.
Yeah. So tell me, what are you creating now? What are you in the process of building?
I'm creating a fan, and I'm going to kind of do this wrong to show why we want to do it the right way, which is common when you're creating these things. So I'm like, okay, I'm creating this fan. It's got a name. It has this Boolean of whether or not it's on. And it's got this functionality besides that state of being able to be broken. I guess this would just be, smashing it or something. As you can see, I'm thinking about how it would sound when it breaks.
Right. Clearly, you've broken a lot of fans.
At least,
because I think that's pretty accurate.
At least 5, perhaps 50. So we have this particular class, and you can see the functionality here, right? And I'm even setting some default things. What's going to happen next is I'm going to actually create something similar. And this is kind of what they will come across when they're developing code, which is like, oh, okay, I built something. And now they're going to build something else. And what's going to happen is they're going to be like, oh, wait, I need all those things.
Everything for fan you need for light.
Yeah. So, but rather than just creating a class that I'm going to extend, I'm going to make it abstract because I don't really... I do need some of that functionality, but the functionality of break fan or break device or break light, I don't want them to have the same thing. I just want them to promise that they're going to have that same method.
Right.
So here I've abstracted out like, well, okay, they both have a name and they both have a is on, but this is where I'm actually showing like, okay, this method is abstract.
Mm-hmm.
I'm like, oh, what? No, I don't want to make that myself. I want someone else to make that.
Right. And so the abstract keyword used for both classes and methods.
Yes. Although you cannot put an abstract method in a concrete class. That's a big no-no. That would be, if we're into that philosophically, that'd be very confusing. So yeah, I mean, and you can see how this makes sense, right? Like a device. Like, what is a device, right? It's really it's a whole genre or ontology of objects. A fan is a device. A light is a device. But you can't really have a device. I mean, I guess you could, but I mean, you're really using it as an abstract word to describe specific concrete things.
Right. Gets all the way back to Plato and his ideal chair.
Yeah. Exactly, right? Like chair. It's like, no, that chair.
Mm-hmm.
Or please not that chair. It's uncomfortable and broken because I fell off of it earlier today.
Yeah.
So here we are just implementing it. If you saw that, Android Studio, again, helps you out so much. Most modern IDEs do at this point. And it'll give you the hint like, hey, you want to extend device? You gotta implement those methods. Also, if glass was everywhere, it really would be that bad. I don't understand how a light could get glass everywhere, but I guess I was assuming that it would.
It's not that bad. It is not that bad, or just
I guess
like it's like glass. It is not that bad. Is it?
No, glass. It not that. Yeah.
Okay.
Yeah, I meant to.
You meant that
to sound like an idiot. Yeah.
Okay.
Yeah. I'm not so great at spelling.
I think you just don't like apostrophes.
You know what? Actually, I don't.
Yeah.
They often will break many languages when you put an apostrophe in there if you don't escape them. So
You're not the only professional developer I've seen actually misspell things because they just have stopped using apostrophes altogether.
That's right. That's right. It's a possible escape character sequence. I want to stay away from those things. You'll notice that most of my emails are all in lowercase as well because I'm just not sure if casing is going to screw it up. So here we are, actually going through, slowly the different pieces that are actually different between fan and light.
Right, giving each its own uniqueness.
Yeah, because they both need to have their device names set.
Mm-hmm.
So that's going to happen. And here I believe I'm actually going to instantiate a fan and a light.
Excellent. So now we have actual objects.
Bam! Created it. From nothing comes fan.
Not all this abstraction.
No, these are concrete things here.
Yeah.
But we're gonna get pretty weird coming up here.
I'm excited.
Yeah, we're gonna start doing some stuff where we're gonna start calling. We're basically going to be pushing the whole static typing idea in Java. We're gonna start pushing that to its limits, and that's gonna be fun.
But first, we got to break stuff.
Well, we have to test it out.
Right.
We have to make sure it breaks.
This is the thing, actually, that I notice novices don't do. They don't test regularly.
I've seen some intermediate professional developers do that as well. But it's a thing where if you test often, you catch things like this, right?
Pipe.
So that actually has nothing to do with my code. That's actually just a problem with Genymotion. But there it is. It works. I know I don't need to go back.
Yeah, that's just it. Is that it's like knowing specifically when is a good time. It's usually if you have any doubt in your mind that what you're doing is working, it's time to test.
Close. That's actually not how I think about it. No.
Okay. Well, how do you? Because I think that would be helpful for everybody to hear.
Because anything can be broken at any time. When I test is when I have a clear separation of concern kind of idea. Like this is supposed to do that. A small chunk, perhaps.
So when you can form a hypothesis that this is what I think should happen or will happen, and then you could test it.
That's part of it.
Okay.
Part of it is more like this is supposed to provide me this functionality. Does it? Is it actually doing what I made it say it was supposed to do with the least amount of dependency? Okay. Right? Like, I just made a thing. Let's see if that works, right? Not let's write all of the code and see if all the code works. Right? I just want to see like does fan and light inherit basic functionality?
Right.
So here, you'll notice that my next testing point, something similar. Here we're actually showing the annoyance of the concrete classes. So now we have a switch. We want to wire our switch up to a fan and a light, but they're different data types. So it's like, okay, if I want my switch to turn on, a fan, then I have to make methods that connect to fan types. And then if I wanted to wire to something that takes a light, I have to do it for light types.
Right.
Now, I could do it for device types.
Well, and I think this is where we start going from novice to pro is, I think it's really about two things. You mentioned one of them already, separation of concerns.
Yeah.
And that really suggests, when you see someone making good choices about the separation of concerns, it suggests that they are a professional, that they have experience.
Right. Well, it really is. I see novices often ask the question, well, where do I put the code? And a pro doesn't ask that, right? A pro has already put the code there, is wondering why it doesn't work.
Right. Yeah.
But this thing of like, what should my code over here be concerned with? Is what makes your code helpful.
So how are you determining what switch should be concerned with?
Well, I'm using a literal metaphor. My switch should be concerned with just turning something on and off. It should not care, just like an actual switch in real life, it should not care what it's wired to. It's just changing the state from, hey, if you have an on state, do the on state thing. If you have an off state, do the off state thing. I don't care what you do about those things. I just want to make sure the message changes.
Right.
And so using that kind of metaphor, you can really see like the lack of dependency of where I'm going. Now, again, you could use device and say like, well, I mean, as you can see here, like I'm doing turn on fan and writing these methods, but when you get further in on this, you'll see that you don't even want to know about device. Like Switch shouldn't even know about the concept of a device. It should just be like, look, I don't. Can you turn on and turn off? Because if you can, then I'm the right class for you.
Right.
So you want to really make it as independent as possible.
Almost normally this wouldn't be good for humans to be this way, but it almost feels like classes should be myopic.
They should. Yes, they should be incredibly myopic. And just unlike humans, humans should, rely and depend on each other and earn trust. Code should not. Code should be the most like skeptical, badass, just like,
I do my thing, and I if you don't interfere with me, then that's great. If you do, you better do it the right way.
Yeah, or not even like do this, do that.
Yeah.
He shouldn't even care whether or not you do it the right way. Like that kind of like opposite.
Right.
I mean, we're basically building like some really hard code here. Like we want our code to be completely independent and reusable,
but not brittle. That's not what you mean by hard.
No, not hard like that. I mean more like hardened, like as though you forged it with steel over and over again.
Got it. Well-tempered.
Well-tempered. Yeah, that's a way cooler word than what I was thinking.
Well, I like words.
It's true, and you like cool words.
Yeah, and I use apostrophes, which you did there.
I did. For some reason, I did there. I got excited. So excited that I kind of stubbed my toe. Yeah. So yeah, now that we're kind of creating that, you can see like, okay, man, if I were to now create like a radio, that would be really annoying because I'd have to create like a turn off radio.
Right.
And turn on radio.
Turn on fan, turn off fan.
And at this point, it's like, what use is the switch class really as a class if I have to write all of the same thing there?
Right. Yeah, it's not really helping you like you want it to.
Right. And even further than that, again, there's the argument of like, well, then why not make it so it takes a device class and deals with a device? Yeah. And the idea is like, why should a switch know about the concept of a device? I mean, why would it?
Yeah, it's just for switching.
It's just for switching. So this is where we're actually defining kind of what Switch is concerned with in a way. We're saying, well, it's going to care about whether or not something is switchable. It's going to care whether or not can it call turn on and can it call turn off. That's all it wants to know.
So it doesn't have to be a device, just as long as it's something that can be turned off and turned on.
Is actually as long as it's switchable.
As long as it's switchable.
Yeah, because that's what a switch does. I wonder if we're going to get to the point yet where we're first.
Let's implement that interface. And again, Java single inheritance, multiple
interface. Yeah.
So really, the power in Java is those interfaces.
And now you can start to see like, okay, showing the error code. Here we are, not I want to say genericizing. That means something. Generalizing kind of our method names. Turn on, turn off. So through here you can kind of see like the evolution of why you would do this, as well as a lot of O's for the word whoosh.
Right. Now, does fan have to extend device and implement switchable, or if it extends device and device implements switchable, does that transfer?
Actually, if device, that's a great question. So
let's get into it.
Okay, let's get into it. If device implements an interface and it's an abstract class,
right?
Because it is not concrete, as in you cannot instantiate it. It's kind of like saying that like, again, like a interface is a contract. So if I said that like, hey, everybody that is a part of our company has to sign this contract. That doesn't mean the company signs the contract.
Right.
So it's actually, if the abstract class does that, if it implements a functionality, that's fine. But it can actually just pass that contract on to something below it. It's just as long as the thing that instantiates it actually is like, I promise, and actually does respond to those method calls, then it's all cool. And so here you can start to see that what's so awesome. I love this so much. This is so cool because now I don't need to write a bunch of code. I can write my code. What you'll end up seeing, I can write my code kind of once, and then for all future generations of all time.
Wow, that sounds intense.
But it's true. Like if you were to come across this code 1,000 years like later from now, right? Mm-hmm. You would look and be like, and let's say like you couldn't see switch, you couldn't see what it does in there. Mm-hmm. You'd say, well, switch is going to end up taking a switchable. So we'll see that slowly come up here. So turn on switchable. Mm-hmm. And we could just read the switchable class and be like, okay, I guess I need to have these two methods. And then that class will work. It doesn't matter. We could actually create a Java class called the Internets. And we could put everything in there. And as long as the entire Internet's implemented switchable, then that switch would work with whatever crazy technology we just created.
Could just turn on and off the Internets.
Yeah.
So you're really, it's almost like you're creating immortal code.
Yeah. Well, I mean, you're creating code that has the ability to specify what it needs to work. And that's really important for dealing with where do I put my code. Mm-hmm. So here, right, like turn on switchable, turn off switchable. Those are different objects, but they signed up for the same contract. Mm-hmm. Or at least we're going to see as soon as I press OK.
Different objects or different methods?
Different types of objects. So turn on switchable my light.
Yeah.
Turn off switchable my fan.
Uh-huh.
The only thing in common with those is they both implement switchable. Mm-hmm. And as you can see, there's glass everywhere, and
I mean, even Genymotion's broken with the broken pipe. Just breaking everything.
Yeah. Well, you gotta break some stuff to kind of build from the ashes.
Yeah. You mixed your metaphors.
I did. They were really badly mixed. I'm really sorry about that.
Are we burning things or breaking things?
We're building things. We're building things. We're building switches and fans and lights that don't actually blow wind or light up.
Okay.
But they do connect to each other with abstract interfaces, which is awesome.
Yeah.
So now we're going to take it to the next level.
Now, we said that there are two things, really, that kind of distinguish a professional coder. Separation of concerns was the first.
Hair was the second.
Hair in the right places.
No, actually, it doesn't matter.
Just hairy.
Just hair.
Okay.
I mean, even if you just like have no hair, that's kind of a state of hair.
Okay. So if you're a developer, don't use Nair.
Yeah, don't use Nair. Just keep whatever state of hair you have, and you'll be good. No, here we go.
But seriously, it's not not just separation of concerns, but this idea of inversion of control.
Yeah. Yeah, because previously, when we were doing all that stuff before, the switch was responsible for understanding what it was turning on and turning off. Mm-hmm. And what we've done is we've inverted that control now. Now it's actually the fan and light that are responsible for knowing how to be switched.
And how are you doing that here? I mean, I've seen you just killed those two methods, but what is it that's allowing this state of inversion?
Okay, so what I'm doing is I'm saying, okay, I'm only going to want to turn things on and off. So I'm going to actually just create a list, in this case an array list, of switchable items. Mm-hmm. And that means that they're objects that I know that respond to the method turn on and turn off. And so at this point, you're not going to see the word fan. You're not going to see the word light. You're not going to see the word device. In fact, again, you can make the internets. And this class, all it cares about is switchables. We've now turned an interface into a type. And that makes it so that we can write code that is really clean, really simple. And more importantly, it doesn't get us involved in this process of like, oh, let me look at a method on light. Oh, and then the method for fan is slightly different. It's like, look, when I type thing, the only methods available to me were just turn on and turn off. It keeps your cognitive load so low. So here I flip switch up is like, hey, anything in that list, call the turn on method. Mm-hmm. Thing, turn off for flip switch down. And now I'm just making methods to say, hey, do you want to register for being able to do this? I'll add you to the list, or I'll remove you from the list if you like.
Mm-hmm.
I mean, another good part about this specifically is this is what's so awesome about Java collections is you can actually remove an object because it will just compare it to where it is in memory. And so I can just do add and remove thing, and a whole lot of like messing with arrays and trying to compare things is just done kind of for you.
Mm-hmm.
So really easy to read, right? Add the thing, remove the thing. Obviously need to change the methods now to that new nomenclature. But yeah, I mean, it's just really awesome to be able to make code that is now able to be reused in another project as long as that interface comes along with it.
Mm-hmm. And there was a power there too that you seem to use with just literally the generic.
What do you mean by that?
I have no idea.
Are you talking about like the generic brackets or just the
I mean, I saw the angle brackets and
Yeah.
I saw switchable and I saw you making a list of that.
Oh yeah, because again, it's a data type. So
Mhm.
later it's going to be filled in behind the scenes
Right.
for with that type with type erasure.
Right.
And so yeah, I mean, you don't even have to have again, it's all these kind of like rules that you set up. You don't actually have to always be so literal. You get this idea of being able to be kind of abstract with your concepts and say, well, look, I don't really care who you are or what you are or how you work. I just want to know, will you do these things?
Mm-hmm.
And that's really all you need most of the time.
And so now as you call these methods, all you really care about are what you're passing in.
What do you mean?
My fan, my light, wire up my fan, wire up my light.
Yeah, I'm not looking for like a wire up my fan method or wire up my light method. I mean, again, you could put the internets in there and it would work. And it's like a literal switch, right? Like a switch has this interface, which is usually with electricity is like a ground and a positive thing. And it's like, well, okay, I have two wires. Do you have two wires? If you give me two wires, I will connect or disconnect those two wires.
Mm-hmm. And here we're seeing that
glass everywhere. We're seeing that I'm losing my keys, and it's hot and stuffy, and it's dark, and then I can see, and then I stub my toe twice. Yeah,
this project was painful for you.
It was a really painful project, but I'm better for it.